to be working on projects recently where I've actually been, basically sharing between our team on GitHub and publishing to CPAN before we do consumer releases. So go to the code CPAN if you want to see the real thing. But with demonize, it's quite simple. You just you can just use these Moose modifiers to say what to do before you demonize and after you demonize.
Is it LSB conformant?
LSB conformant. Oh, the inner scripts. Are you talking about? Are you talking about like an inner script?
Exactly. Yeah.
This doesn't. It sort of is like you could possibly link the inner script to it. It works a little bit like that. But mostly daemons sort of you expect them to have an inner script wrapper. So I didn't worry too much about that as long as the program itself supported options to start and stop. And indeed, the examples in the example program, it is kind of LSB like there. You run it with start stop. It's the first open. But this is the calling program. I mean, I don't think I've trimmed anything out of that book. And it's quite a nice pattern. You can say, right, instantiate an instance of my application, and then do the call method on it, corresponding to what they want to do. An example here of keeping it simple, not going daemon error dollar command. Anyway. So, and of course I also had to have logging. This is right here in circle. So I've been using MooseX log for Perl, and finding it quite nice. It doesn't have that much time to loading. That's a bit thought to be a heavy module. And this one has a MooseX. This is one of those examples of modules which doesn't really have a very good excuse for being a MooseX, other than users kind of look in MooseX sort of for things to supercharge their Moose classes. And it doesn't really do anything, it doesn't deliver any functionality, so it's kind of, I think that it does, but it's still belong in the MooseX space. But the thing is, once you've got these modules together, these four modules, you've already got a nice framework for quite a nice friendly daemon that behaves like you want daemons to behave. And so you can put nice, your debugging assertions, that sort of thing, all through it, and then adjust your logging levels in the configuration file, which is, you could really ask for more from a set of modules which just give you infrastructure. Solving a lot of problems that previously I've had to solve in nasty ways. They all use meta class traits, and I've talked about this before a little bit. This is why they're good. This namespace here, Moose meta maybe class custom trait, Moose meta action custom trait. If you deliver a particular function into that namespace, then you've made a trait which makes it easy for people to apply the role that you've defined, the role that you set up to their meta class. It's doing that using actual. You can do it as well without using the trait, without using the trait's declaration, but it's very arcane. The nice thing about using traits rather than inheritance for extending those meta classes is that they stay. So we'll be talking a little bit more about praying later. Praying exports and should. So if you can sort of change your has actually to say has actually to say, right, this about traits is you don't have to define it that way. Because I defined a loose meta attribute custom trait prang class, I can also use it in this way, where I just say traits, I give it a list of traits, and if you give it multiple traits, they can all stack up. They all stack up and go onto the Moose meta attribute object, which describes that particular property. And those modules, those traits can define extra properties the attribute can have. And this is proving to be quite a good way to in general, extend Moose class building. In this case, to make classes which can be easily serialized to XML. So, yeah, so I was saying there's the program I've been working on. It's basically it converts from one XML language to another, so it makes it double enterprise level. And it does use all these modules. One thing I found quite happy after doing it all is that I could test it, and I didn't need to make a compile or anything. I just pass a bunch of command line arguments and away it went. So that was fun. Yeah. So Moose types. This is quite nice for building type libraries. One of the things that Moose users are finding is that more and more of their programs are moving into type declarations, and less is actual code. It's one of those things that I've been saying is that I've stopped coding and I just write types and coalition rules. So MooseX types is a nice way of keeping your types organised, and there's a couple of modules there which really should use it, but don't. Now I'm going to talk about a few modules which, in an abstract, well, you don't normally use directly, but which build up into something quite awesome. Moose also has this idea of structure types. So this is a bit like a tuple that you might have in a database, or a struct, like a C struct with members of particular types. And using type structures, you can define types, which is, say here's one that's a sequence of an object, an array reference which must contain string objects, as in null scalars, and then an object which must be is a sum object, or match the sum object type constraint. So that's quite a useful building block. The other building block is a module called parsing method signatures, which is all about taking POSIX type declarations, parsing them using PPR and producing a MooseX type structured object. And this is basically your POSIX signature object. And it has two parts. It has a list of ordered arguments, some of which may be optional, and a hash of named arguments. And each of those will have a type. So the MooseX type structure is powerful enough to support that. Parse method signatures can parse the string signature and turn it into those. Then, with the fun of developer Claire, we can hook into the Alexa of Perl and deploy these modules during compile time. In theory, there's a new Perl 5.12 XS API for doing this as well, which should make it hopefully a bit less crack field. So, MooseX method signatures pulls these pieces together, and it's no speeding, but it is very useful for saving in your for saving just some pretty mundane code. To shift up arguments off the stack and maybe check if they're the same. You can get all that with one go by using this module. Then you can write method and say, right, the first argument has got to be that class, and put it into a variable with the scope of that. And the last thing, and you get a $self that you can use as well. You don't actually declare it. Cuts out a lot of code, makes things very readable, and it means that on every single method call you're getting type safe checks. So you tend to catch errors earlier, which is what type safety is supposed to be about. So yeah, so yeah, there's been a comment on some of the modules that this is kind of bleeding into stuff, and it is in a way that I've been using it for about a year, and it's been actually the only complaint I've got is that when you get an exception, you really just kind of get a big stack done. And this is something that I've been trying to get a lot of the MooseX community to work together on fixing. And certainly Val, I know very much, has been talking about avoiding string errors. And there's a lot of people that are really big fan of MooseX Vilain, which takes the entire definition of the class, and you can do that in a very processed way. And I don't personally use it, but I don't think that it's necessarily that doesn't say as some people might think. If that makes any sense. So yeah, I don't have an example of that, unfortunately. But if you don't like the slowness and sort of the nature of MooseX signatures, there's some software on CFAN as well that does something quite similar. And it's faster. Right, MooseX attribute helpers. Now, it's called MooseX Limited Attribute Native. It's Golden Core. It's one of these MooseX modules which is actually been a prototype for a Moose core feature. And what this lets you do, is add. Okay, what the thing actually traits us to do is treat an attribute that's actually just got a value in it, like a number, or maybe it's an array or a hash, and treat it like as if it was an object, and say, right, well, if I call the add next method on this class, call the add property on the value in here, but it's a number. So a number it can't handle method calls. It's just a